right, this is just a page of definitions of the different topics we've been dealing with so far in this chapter. So the first thing I have here is the average rate of change. And if you notice, it basically looks like slope. So it is the change of the output B minus the output at A over B minus A. And what this gives us is the slope of the secant, which again, remember secants are 2 points and they intersect at the function and along with the secant, and let's add the word line there. So if you take a look at this graphically, we have the blue secant line and the green function, and that slope of the secant line gives us that average rate of change. So we also talked briefly about the average velocity, and that basically is still the change in the output over the change in the input. And again, this is when we have two specific input values. So this is very similar to the average rate of change. It's just called velocity when we have a position function, and that is usually indicated by S of t. Okay, the official definition then of the instantaneous rate of change is the limit as your decreasing little value. In this case, I have the h. So this is the part that's decreasing and decreasing, approaching zero, so that we can see that limit as it approaches, as we are calculating it for the value x. All right, we can also look at this instantaneous rate of change when we have a position function. And that's when we're going to be talking about velocity and things of that sort. So the way this definition would be the position function at t and that little change in t minus the function. And then we have the t and then change in t minus t. So this again, you guys, is basically like having the, let's write it this way. This is like S of B minus S of A all over B minus A. But again, since it is a limit, we're talking about this change. So what else can we know? So this is saying the limit is as the change h approaches 0. And of course, we could also have that delta t, which I guess is what I just said right over here. The delta t, and we're actually finding a value at the instant time t. And remember, instantaneous also has that word instant in its official definition. So limit as the change approaches 0 is often ends up being a function in terms of c. What is this? This is also the slope of the tangent line. And again, when we are talking about a position function, we're talking about velocity. So one thing to make sure that we understand is the S of t, the position function at a time t, that is its position. But when we are talking about the limit, that is what gives us the velocity. The limit gives us that amount of velocity at that specific time of t. So what does this look like graphically? We would have a function in the green. We're going to have a tangent at this one point. A tangent touches a function at one point. And so again, that instantaneous is the slope of the tangent line. All right, so that was just some of the definitions with a little bit more explanation. And if you have any questions, be sure and let me know. See you next time.